NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we will simplify algebraic fractions by factoring and canceling common factors. We will follow a clear three-step structure. Show the expression, factor it to expose common parts, and then cancel the common factors to simplify. Let's get started. Rule number 1 we will use is the fraction simplifying rule. If we have a times b over a times c, we can cancel the common a, and get b over c, provided a is not 0. We'll use this to simplify our first expression. Step 1. We simplify the fraction, 2a squared x cubed over 4ax squared. First, factor numerator and denominator to expose a common factor. We write it as ax times 2ax squared in the numerator, over 2 times 2ax squared in the denominator. Now, the common factor 2ax squared cancels. The simplified form is ax over 2. Next rule, the difference of squares. If we have a squared minus b squared, it factors into a minus b times a plus b. We'll apply this in step 2. Step 2. Simplify the fraction a squared minus 4 over a plus 2. Factor the numerator as a minus 2 times a plus 2. The a plus 2 cancels, with the denominator a plus 2. The simplified expression is a minus 2. Final rule, factor quadratics and cancel common factors. We factor the numerator and the denominator into linear factors and then cancel any common factor. Let's apply this in step 3. Step 3. Simplify the fraction x squared minus 2x minus 8 over x squared minus 9x plus 20. Factor the numerator as x minus 4 times x plus 2, and factor the denominator as x minus 5 times x minus 4. In this lesson, we'll simplify rational expressions by factorization. We'll use 3 key ideas: difference of squares, factoring out common powers, and canceling common factors carefully while noting domain restrictions. Example 1. Simplify the fraction x squared minus 25 over 5x minus x squared. Step 1. Factor numerator and denominator. Use the difference of squares rule. A squared minus b squared equals a minus b times a plus b. The numerator becomes left parenthesis x minus 5 right parenthesis times left parenthesis x plus 5 right parenthesis. The denominator is x times left parenthesis 5 minus x right parenthesis. Step 2. Use the negative sign trick for 5 minus x, which equals negative of x minus 5. Rewrite the denominator as negative x times left parenthesis x minus 5 right parenthesis. Step 3. Cancel the common factor x minus 5 from numerator and denominator. Step 4. Clean up the negative sign. The simplified result is negative of x plus 5 all over x. Always state domain restrictions from the original denominator. X is not equal to 0 and x is not equal to 5. Example 2. Simplify the fraction x to the 7th power plus 2x to the 6th power plus x to the 5th power over x cubed times left parenthesis x plus 1 right parenthesis to the 8th power. Step 1. Factor the numerator by taking out the greatest common factor x to the 5th. That gives x to the 5th times left parenthesis x squared plus 2x plus 1 right parenthesis. Recognize a perfect square, trinomial x squared plus 2x plus 1 equals left parenthesis x plus 1 right parenthesis squared. Rewrite the numerator accordingly. Step 2. Use exponent rules to simplify same bases. Subtract exponents on x and on x plus 1. The simplified result is x squared over left parenthesis x plus 1 right parenthesis to the 6th power. Domain restrictions from the original denominator. X is not equal to 0 and x is not equal to negative 1. Example 3. Simplify the fraction 3x squared minus 9x over x squared minus 9. Step 1. Factor numerator and denominator. The numerator is 3x times left parenthesis x minus 3 right parenthesis. The denominator is left parenthesis x minus 3 right parenthesis times left parenthesis x plus 3 right parenthesis. Step 2. Cancel the common factor x minus 3. The simplified result is 3x over x plus 3. Domain restrictions from the original denominator. X is not equal to 3, and x is not equal to negative 3. In this lesson, we will simplify rational expressions by factoring and canceling common factors. We'll work through 2 examples step by step and finish with a quick rule about negative signs in fractions. First, our example overview. A useful rule: factor quadratic expressions. We can write ax squared plus bx plus c as left parenthesis x minus our 1 right parenthesis times left parenthesis x minus our 2 right parenthesis, where our 1 and our 2 are the roots. Example 1. Step 1. Factor the numerator and denominator of the fraction x squared minus 6x minus 7 over x squared minus 10x plus 21. We factor the numerator into left parenthesis x minus 7 right parenthesis times left parenthesis x plus 1 right parenthesis. We factor the denominator into left parenthesis x minus 7 right parenthesis times left parenthesis x minus 3 right parenthesis. Rule: cancel common factors. If a product c appears in both numerator and denominator, we can cancel it, a times c over b times c equals a over b, as long as c is not 0. Step 2. Cancel the common factor x minus 7. We highlight x minus 7 in both numerator and denominator, then cancel them. The simplified result is x plus 1 over x minus 3. Note the domain restriction from the original x cannot equal 7 or 3. Another useful rule: perfect, square, trinomials, and difference of squares. X squared plus 2a, x plus a squared equals left parenthesis x plus a right parenthesis squared. A squared minus b squared equals left parenthesis a minus b right parenthesis times left parenthesis a plus b right parenthesis. Example 2. Step 1. Factor the numerator and denominator of x squared plus 6x plus 9 over x plus 9 over x squared minus 9. The numerator is a perfect square, left parenthesis x plus 3 right parenthesis squared. The denominator is a difference of squares, left parenthesis x plus 3 right parenthesis times left parenthesis x minus 3 right parenthesis. Now cancel the common factor. We can cancel 1 copy of x plus 3 that appears in both numerator and denominator. Step 2. Cancel x plus 3. We will visualize the square in the numerator as 2 factors x plus 3 times x plus 3, so we can cancel 1 copy with the denominator. The simplified result is x plus 3 over x minus 3. Note the domain restriction from the original x cannot equal negative 3 or positive 3. Finally, a quick reminder about negative signs in fractions. A single negative can sit in front in the numerator or in the denominator, and all are equivalent. Great job! The fractions are simplified successfully. In this example, we will simplify 3 rational expressions by factorization. We will factor the numerator and denominator, cancel common factors carefully, and write the simplified result. Let's begin. Example: simplify each fraction by factoring and canceling common factors. Rule: factor out common terms in the numerator and in the denominator. Then cancel any identical factors. Remember, we can only cancel factors, not terms being added or subtracted. Problem 1. Simplify the fraction y squared z plus y cubed over z squared y plus z cubed. We will factor the numerator and denominator. The numerator has a greatest common factor y squared. The denominator has a greatest common factor z squared. After factoring, we have y squared times z plus y over z squared times y plus c. The binomials z plus y and y plus c are the same, so they cancel as a common factor. The simplified result is y squared over z squared. Rule: factor out common terms and cancel powers. For example, if the numerator contains a factor a times b minus c and the denominator contains a times b minus c squared, then 1 factor of b minus c cancels, leaving 1 in the denominator. Problem 2. Simplify the fraction 3x squared minus 3xy over 3 times the quantity x minus y squared. We factor 3x from the numerator. That gives 3x times x minus y over 3 times x minus y squared. Now the factor 3 cancels, and 1 factor of x minus y cancels with 1 in the denominator. The simplified result is x over x minus y. In this example, we will simplify 3 algebraic fractions by factorization. We will factor out common terms, cancel matching factors carefully, and keep an eye on restrictions so that we never divide by 0. First, let's look at a quick rule for factoring out a common term. Problem 1. Factor each part. For ax plus 8, y has a common factor of 4a. And 3bx plus 6, by has a common factor of 3b. So the fraction becomes 4 times x plus 2y over 3b times x plus 2y. The factor x plus 2y appears in both numerator and denominator, so it cancels as long as x plus 2y is not 0. We get 4 over 3b. Restriction x is not equal to negative 2y. A helpful reminder for quadratics. We can factor ax squared plus bx plus c into linear factors when possible. Problem 2. Factor top and bottom. X squared minus x minus 6 factors as x minus 3 times x plus 2. X squared plus 4x plus 4 factors as x plus 2 squared. So the fraction is x plus 2 times x minus 3 over x plus 2 squared. Cancel one copy of x plus 2 from numerator and denominator, provided x plus 2 is not 0. The simplified form is x minus 3 over x plus 2. Restriction x is not equal to negative 2. Another pair of rules that often work together. Factor by grouping and factor a difference of squares. Problem 3. Group the numerator. Ax minus bx minus y plus by becomes x times a minus b minus y times a minus b, which factors to a minus b times x minus y. The denominator has b squared minus a squared, which is b minus a times b plus a, and then times x minus y. So we have a minus b times x minus y over b minus a times b plus a times x minus y. Cancel x minus y, as long as x is not equal to y. Notice b minus is the negative of a minus b. Replace b minus a with negative 1 times a minus b. The simplified result is negative 1 over a plus b. Restrictions x not equal y, and a not equal plus or minus b. In this lesson, we will simplify algebraic fractions by expanding, canceling common factors, and factoring special identities. We'll work through 3 examples step by step, and I will highlight every move so you can see exactly why it works. Example: we will start with a product over a product, expand it into separate factors, then cancel common factors between numerator and denominator. Rule: expand and cancel common factors. When we write a product as separate pieces, it becomes easy to see what cancels. Step 1. Show the expression. Step 2. Expand numerator and denominator into separate factors. Step 3. Cancel the common factors a squared, x, and y on top and bottom. Step 4. Simplify the remaining constants and powers. 14 times 5 times 6 over 15 times 7 reduces to 4. For b, we use the quotient of powers rule. B to the 4 over b to the 3 equals b to the 1. So the result is 4b. Now example 2. We will combine powers in the numerator and denominator first, then cancel common factors and simplify the constants. Step 1. Combine like bases by adding exponents in the numerator and in the denominator. Here, a to the 2 times a to the 7 becomes a to the 9, and so on. Step 2. Cancel c to the 5 and d to the 3 because they appear on top and bottom. Then simplify the constants. 34 times 6 over 51 reduces to 4. Finally, subtract exponents for a and b. We get a to the 4 and b to the 5. Finally, example 3. We will use a factoring identity. The numerator is a sum of cubes, and the denominator can be simplified to match the quadratic factor from the numerator. Step 1. Factor the numerator using the sum of cubes identity. Step 2. Expand the denominator and collect like terms. Step 3. Cancel the common quadratic factor a squared minus ab plus b squared. We are left with a plus b. Great work! We expanded products, canceled common factors, used power rules, and factored a sum of cubes to simplify each fraction. In this lesson, we will simplify 3 rational expressions by factoring, then canceling common factors. Along the way, we will recall perfect, square, trinomials, difference of squares, grouping, and the difference of cubes. Rule reminder: a perfect square, trinomial a squared plus 2, a b plus b squared equals open parenthesis, a plus b close parenthesis squared. And difference of squares, a squared minus b squared equals open parenthesis, a minus b close parenthesis times open parenthesis, a plus b close parenthesis. Example A. We simplify the fraction 4a squared plus 12a plus 9 over 4a squared minus 9. The numerator is a perfect square, and the denominator is a difference of squares. We factor the numerator as open parenthesis 2 a plus 3 close parenthesis squared. We factor the denominator as open parenthesis 2 a minus 3 close parenthesis times open parenthesis 2 a plus 3 close parenthesis. Now, we rewrite the square in the numerator as a product to see the common factor clearly. We cancel one copy of 2 a plus 3 from the top and bottom, and we get the simplified result. Rule reminder: factor a trinomial ax squared plus bx plus c by grouping, so that it splits into open parenthesis mx plus n close parenthesis times open parenthesis px plus q close parenthesis. Example B. We simplify the fraction 12ax squared plus 3ax over 8x squared plus 22x plus 5. First, factor the numerator. Both terms share 3ax, leaving 4x plus 1. Now factor the denominator by grouping. We split 22x as 20x plus 2x. Group and factor 2x times open parenthesis 4x plus 1 close parenthesis plus 5 times open parenthesis 4x plus 1 close parenthesis. So the denominator is open parenthesis 4x plus 1 close parenthesis times open parenthesis 2x plus 5 close parenthesis. Now build the factored fraction and cancel the common factor 4x plus 1. And write the simplified result. Rule reminder: difference of cubes x cubed minus a cubed equals open parenthesis x minus a close parenthesis times open parenthesis x squared plus a x plus a squared close parenthesis. And x squared minus 3x plus 2 equals open parenthesis x minus 1 close parenthesis times open parenthesis x minus 2 close parenthesis. Example C. We simplify the fraction 16x cubed minus 128 over 8x squared minus 24x plus 16. First, factor out constants. 16 times open parenthesis x cubed minus 8 close parenthesis over 8 times open parenthesis x squared times open parenthesis x squared minus 3x plus 2 close parenthesis. Now factor the difference of cubes in the numerator and factor the quadratic in the denominator. Build the factored fraction, cancel x minus 2, and simplify the constant 16 over 8 to get 2. Finally, write the simplified result. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.